Bismillahirrahmanirrahim. Exercise 2.3, question number 2, part 3. Solution. Let A equals to this. First we will find determinant of A. 2, 1, 2, minus 3, 0, minus 2, 0. Minus 2, minus 2, 2, 1, cancel these, minus 2 into 2, minus 2 into 2, minus 2 into 0, here minus 2, cancel these two, 0 into 2, minus 2 into 0, then minus 3, 0 into minus 2, minus 2 into minus 2, here 2 2s are minus 4, minus into minus plus, 2 zeros are 0, here minus 2, 0 2s are 0, and minus into minus plus, 2 zeros are 0, minus 3, 2 zeros are 0, and minus into minus plus, 2 2s are 4, minus 4, here 0 plus 0, 0 0 into minus 2, 0, and here 4 3s are minus 12. Minus 4 minus 12 we get minus 16. Not equals to 0. A is non-singular matrix, so its inverse exists. A is non-singular matrix, so its inverse exists. Now write the augmented matrix. 1 2 minus 3, 0 minus 2, 0, minus 2 minus 2, 2, right here 1 0 0, 0 1 0, 0 0 1. Row operation. First of all, multiply R1 with 2 and subtract it from 3. So 2 1s are 2, minus 2 and plus 2, add it, minus 2 plus 2 we get here 0. Here 2 2s are 4, minus 2 plus 4 we get here 2, and 2 3s are 6, so 2 minus 6 we get minus 4. Here 2 1s are 2 plus 0 we get 2 and 0 here, and write the rest of the element on its place. 1 0 0, 0 1 0. So how? By R3 plus 2 times R1. Row operation. Now R1 plus R2, add this with this, so minus 2 plus 2 we get 0, 1 0, and here minus 3, here 1 plus 0 we get 1 and 0. Now R3 plus R2, add these two we get here 0, and here minus 4 on its place, here 2 1 and 0. and write this row on its place. 0, minus 2, 0, 0, 1 and 0. How? By R1 plus R2 and R3 plus R2. Now row operation. Multiply this with minus 1 over 2 and this with minus 1 over 4. So here write this on its place. 0, minus 3, here 1, 1, 0. Multiply this minus 1 over 2, so 0. Here we get 1, here 0, here 0, and here minus 1 over 2 and 0. And write this with multiply this with minus 1 over 4, so 0, 0. Here we get 1, and here we get minus 1 over 2, and here we get minus 1 over 4. And here is, look, this one comes here, this one, so minus 1 over 4. How? Minus 1 over 2 R2 and minus 1 over 4 R3. Now multiply this with row third with 3 and add it with this, so here we get 0. Row operation. Here we get 1, 0 and 0. Multiply this with 3, so it become minus 3 by 2, and add it with this 1 minus 3 by 2, so we get minus 1 by 2. Look here, 1 minus 3 by 2, 2 ones are 2, 2 minus 3 by 2, we get minus 1 by 2. So here write minus 1 by 2. Now minus 3 by 4, 1 minus 3 by 4, we get 1 by 4. And minus 3 by 4, so 0 minus 3 by 4, we get minus 3 by 4. And write this on its place. 0, minus 1 over 2, 0, and here 0, 0, 1, minus 1 over 2, minus 1 over 4, and minus 1 over 4 on its place. How? R1 plus 3 times R3. So what we get here, look here, this is A inverse. A inverse equals to minus 1 over 2, 1 over 4, minus 3 over 4, 0, minus 1 over 2, 0, and here minus 1 over 2, minus 1 over 4 and 0 on its place. The answer. Part 4. Let A equals to this, determinant of A, 1 minus 1 into 2 minus 0 into 3 minus 2, cross this, 0 into 2, minus 1 into 3, and here minus 1, 0 into 0, 1 into minus 1. So here we get minus 1 into 2, we get minus 2, and here 0 into 3, we get 0. Write minus 2 on its place, 2 zeros are 0, and 3 ones are minus 3. Here minus 1, 0 zeros are 0, and minus 1 into minus 1, we get plus 1. Now 1 into minus 1, we get minus 1, minus into minus plus, 3 twos are 6, and minus 2. So here we get 6 minus 3, 3 not equals to 0. A is non-singular matrix, so its inverse exists. Now the augmented matrix can be written as, this is A and this is 1 0 0 0 1 0 0 0 1 identity matrix. Now we will apply row operation. So first row operation, R3 minus R1. So this 1 minus 1 we get 0, and 0 minus 2 we get minus 2, and 2 minus minus 1, so 2 plus 1 equals to 3. And here 0 minus 1, so minus 1, 0 minus 0, 0, and 1 minus 0, we get 1. Now here R1 plus 2 times R2. This is 2. Okay, R1 plus 3 times R2, so multiply this R1 plus 2 times R2, multiply this by 2, so 2 minus 2, we get 0 here, and 3 2s are 6, minus 1 plus 5, we get minus 1 plus 6, we get 5, and here 1 on its place, and 2 1s are 2, 0 plus 2, we get 2 and 0. And similarly R3 minus 2 times R2, so multiply this with 2, so minus 2, minus 2, minus 2, so plus 2, so here we get 0, and here 6, 3 minus 6, we get minus 3, and here minus 1 minus 8, here is minus 1, so 0 minus 1 on its place, and here 2 1s are 2, 0 minus 2, we get minus 2, and here 0, so 1 on its place. Now R2 plus R3, add this row with this, so 0 minus 1, we get here minus 1, minus 3 plus 3, we get 0, minus 1 plus 0, we get minus 1, 1 minus 2, we get minus 1, and 1 plus 0, we get 1, and write the next row on its place. Now multiply this second row with minus 1 and this with minus 1 by 3. So this will become 1, this will become 1, 1 and minus 1 over 3, so it become 1, minus into minus 1 over 3, it become 1 over 3, and it become minus 2 over 3, and it's become 1 over 3. Now row operation, R1 minus 5 times R3, multiply this with 5 and subtract it, so we get here 0, and here 5 over 3, 1 minus 5 over 3, we get minus 2 over 3, 10 over 3, 5 2s are 10, 10 over 3, so 2 minus 10 over 3, we get minus 4 over 3, and here minus 5 over 3, 0 minus 5 over 3, so plus 0 minus into minus plus 5 over 3, we get here 5 over 3, and write the rest on its place. Now this is the inverse. A inverse equals to this answer.